Good morning, students. So far, we have studied about inverse trigonometric functions. Now, there are some properties of inverse trigonometric functions. These are also the formulae to solve the questions of the exercises. Now, all properties are in their restricted domain of trigonometric functions. First property is sine inverse x is equal to x. Sine and sine inverse both removed. Also, sine inverse sine x is equal to x. Here also sine inverse and sine removed. Similarly, cos inverse x is again x. Also, cos inverse cos x is equal to x. And similarly, tan inverse x is x, and tan inverse tan x is equal to x, etc. The same property will hold in all trigonometric functions. Now I am taking proof of first one. Let sin x is equal to phi implies that x is equal to sin phi. That means replace the value of phi by sin inverse x, which is already considered. So x becomes sin inverse x. Similar proof is for all other parts. Now property number 2, sin inverse 1 upon x is equal to cosec inverse x. Cosec inverse 1 upon x is equal to sec inverse x. Tan inverse 1 upon x is equal to cot inverse x. Similar way we can say cosec inverse 1 upon x is again sin x. Sec inverse 1 upon x is equal to cos inverse x, and cot inverse 1 upon x is equal to tan inverse x. Proof of first one. Let sin inverse 1 upon x is equal to phi. Then by the definition 1 upon x will be equal to sin phi. So 1 upon x is sin phi, then reciprocal of 1 upon x gives you the reciprocal of sin phi, that is x is equal to, and reciprocal of sin phi, that is cosec phi. That means phi is equal to cosec inverse x. Thus we see that sin inverse 1 upon x is equal to cosec inverse x, and similar way the other parts can be proved. Now property number 3, sin inverse minus x is equal to minus sin inverse x. Tan inverse minus x is equal to tan inverse x. Cosec inverse minus x is equal to minus cosec inverse x. Cos inverse minus x is equal to pi minus cos inverse x. Sec inverse minus x is equal to pi minus sec inverse x. And cot inverse minus x is equal to pi minus cot inverse x. We can prove any one of these all. Now I am taking its fourth part, that is cosec inverse minus x is equal to pi minus cos inverse x. Let cos inverse minus x is equal to phi. Then what, according to definition, minus x is equal to cos phi. This implies x is equal to minus cos phi. That means x is equal to cos pi minus phi. We will see the principal value branch of cos, that is 0 to pi, first to second quadrant, and in second quadrant cos is negative and the value of angle is pi minus phi. Thus we see that cos inverse x is equal to pi minus cos inverse minus x. That implies cos inverse minus x is equal to pi minus cos inverse x. And similar way we can prove all other parts. Now property number 4. First, sin inverse x plus cos inverse x is equal to pi by 2. Second, tan inverse x plus cot inverse x is equal to pi by 2. Third, cosec inverse x plus sec inverse x is equal to pi by 2. I am taking the proof of first one. Let sin inverse x is equal to phi. This implies x is equal to sin phi. So x is equal to, now change sin into cos. Cos, in case cos 90 minus theta is sin theta. Similar way, x is equal to cos pi by 2 minus phi. That was sin phi. Now taking cos right hand side, cos inverse x becomes pi by 2 minus phi. So cos inverse x is equal to pi by 2 minus sin inverse x, as phi is sin inverse x we have already taken. Now taking one side, sin inverse x plus cos inverse x is equal to pi by 2. This is the proof of first one. Similarly we can prove other parts. Now property number 5. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, xy less than 1. You can resemble this. Tan a plus b is equal to tan a plus tan b upon tan a 1 minus tan a into tan b. Similar way, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. And like tan inverse a minus tan inverse a minus b, that is equal to tan inverse a minus tan inverse b upon 1 plus tan inverse a into tan inverse b. Similar way, second one is tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy, where xy greater than minus 1. This is the domain. And third one is 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. We can take any one of these to prove, and similar way other part can be proved. First one I am taking, that is, let tan inverse x is equal to a and tan inverse y is equal to b. So this implies x is equal to tan a and y is equal to tan b. Now we have the formula tan a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b. That means tan a plus b is equal to, and replace the value of tan a tan b as x and y. That becomes x plus y upon 1 minus xy. Now taking tan right hand side, a plus b is equal to tan inverse x plus y upon 1 minus xy. Now we see from above, a is tan inverse x, replace it, and b is tan inverse y, replace it. We get tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Similar way we can prove second one, and similarly third one. In case of third one, we can write 2 tan inverse x is equal to tan inverse x plus tan inverse x. And now apply the formula tan inverse x plus x upon 1 minus x into x, and thus we can get the result. Now property number 6, 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square mod of x less than equal to 1. This is the domain. 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square, x greater equal to 0. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square, x lies between minus 1 and 1. Here we have three formulae for 2 tan inverse x. 2 tan inverse x in the form of sin inverse x, 2 tan inverse x in the form of cos inverse x, and 2 tan inverse x in the form of tan inverse. We can prove any one of these. I am taking the first one. We know that the formula from trigonometry, sin 2a is equal to 2 tan a upon 1 plus tan square a. In this formula, we can put tan a is equal to x. So a is equal to tan inverse x. Now put the formula, put the values. Sin 2a becomes 2 and tan a is x, 2x upon 1 plus tan square x, that is x square. It means that is 2x upon 1 plus x square. Now taking sin right side, 2a becomes sin inverse 2x upon 1 plus x square. And a is tan inverse x, so that becomes 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. This is the proof. Now in case of second one, we take another formula of tan a of cos 2a in the form of tan a. That is cos 2a is equal to 1 minus tan square a upon 1 plus tan square a. Here 1 plus tan square a in the denominator. It is misprinted here. And in this we again put tan a is equal to x. And then similar way we can prove the formula of second one. And in case of next one, we know the trigonometric formula for tan 2a, that is 2 tan a upon 1 minus tan square a. Put tan a is equal to x, and again in the similar way we can prove the formula of third one. Here some misprint is here, third and second, these are third and fourth, these are not third and fourth, these are second and third. So see above, and these are the results, these are the properties which are yellow colored, which are mainly used in the solving questions, in solving the questions. So we have to remember these all and practice these for solution of exercise questions. Now we have to learn about conversion of inverse trigonometric functions. How will you convert? As sin inverse x in form of cos inverse, in form of tan inverse, in form of cot inverse, like this way. Suppose I am taking sin inverse x, we have to change this. We know that sin is the ratio of perpendicular and hypotenuse is right triangle. If sin inverse x, here x is equal to perpendicular upon hypotenuse, that will be x upon 1. It means its perpendicular is x and hypotenuse is 1 in right triangle, And now we calculate for base using Pythagoras. So we get base is equal to under root 1 minus x square. Now find cos. Cos is base upon hypotenuse. From this triangle we can find under root 1 minus x square upon 1, that is under root 1 minus x square. And similar way, tan is the ratio of p perpendicular and base from this triangle. So this becomes x upon under root 1 minus x square. Thus we see that sin inverse x is equal to cos inverse under root 1 minus x square, and that is equal to tan inverse x upon under root 1 minus x square. Thus we can change sin inverse into cos inverse, tan inverse, and like this way. We have to remember these for changing. Remember, sin inverse perpendicular upon hypotenuse is equal to cos inverse base upon hypotenuse is equal to tan inverse perpendicular upon base is equal to cot inverse base upon perpendicular equal to sec inverse hypotenuse upon base equal to cosec inverse hypotenuse upon perpendicular. And this way we can change one form to another form by drawing a triangle, and perpendicular base hypotenuse are to be calculated and put the values. We can convert one inverse trigonometric function to another. Now I am taking a small example from your exercise, that is, how will you prove the question 3 tan inverse x is equal to sin inverse 3x minus 4x cube, and it is the domain given in which this function is defined. X is equal to x is taken from closed interval minus half to half. So how will you solve? Solution is this: let sin inverse x is equal to a. That means sin a is equal to x. So what happens to left hand side? This becomes 3 sin inverse x, that is equal to 3a. And in right hand side again put the value of x, sin inverse 3 sin a minus 4 sin cube a, as x is equal to sin a. So this becomes sin inverse, and this is the formula for sin 3a. So sin inverse and sin cancel out and removed will give you 3a. Thus we see that left hand side and right hand side are equal. So the equation is verified. Now another question from the exercise, that is tan inverse 2 upon 11 plus tan inverse 7 upon 24 is equal to tan inverse 1 upon 2. Now we use the formula in left hand side. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. This is the formula. And here in this case 2 upon 11 is in place of x and 7 upon 24 is in place of y. So left hand side becomes tan inverse 2 upon 11 plus 7 upon 24 upon 1 minus 2 upon 11 into 7 upon 24. After calculation, we get tan inverse 2 into 24 plus 7 into 11 by 11 into 24 minus 2 into 7, as 11 into 24 from denominator of numerator and denominator both are cancel out, both the LCMs of numerator and denominator. So cancel out, we get tan inverse 125 upon 250, that is in lowest form tan inverse half, that is the right hand side. Thus we see that left hand side and right hand side are equal. Now you have to practice examples uh, before your exercise, that example number 3, 4, 5, 7 and 8. Okay, thank you. Have a good day.